Now student, let's solve another numerical, and the question is, find the equivalent resistance between the points P and Q of the given network. And the student, the network given to us is these are points P and Q. This is of 1 ohm, this is of 1 ohm, this is of 2 ohm, this is 1 ohm, 1 ohm, this is 2 ohm, and this is 1 ohm. Student, we have to find out the equivalent resistance between P and Q. Student, let's name these resistances as R1, R2, R3, R4, R5, R6 and R7. Student, we know that these two resistances, that is R1 and R2, see, these are connected in series. R1 and R2 are connected in series. So student, we get the equivalent resistance RS by adding R1 and R2, and we will get it as 1 plus 1, which is 2 ohm. So student, the equivalent resistance of these two resistors comes out to be 2 ohm. Now student, see, the combination of R1 and R2 is now connected in parallel with R3, that is student now RS and R3. Now RS and R3 are connected in parallel combination. So student, we will get the equivalent resistance as 1 by Rp, which is equal to 1 by Rs plus 1 by R3. Student, we have calculated the value of Rs, which is 2 ohm. So this is 1 by 2 plus R3 is also of 2 ohm. So we will get the equivalent resistance as 1 ohm. Hence student, Rp comes out to be 1 ohm. Now students, see here, R5 and R6 are connected in series. R5 and R6 are connected in series. So again we will get the equivalent resistance of R5 and R6 as Rs prime, which is 1 plus 1, 2 ohm. Now student, this Rs prime and R4, these two are in series. And student, the equivalent resistance of RS, R5 and R6 is connected in parallel combination with R4. So student, RS prime is connected parallel with R4. So student, RS prime and R4 are connected in parallel combination. So we get the equivalent resistance as Rp prime as 1 upon Rp prime is equal to 1 upon Rs prime plus 1 upon R4. This is 1 by 2 plus 1 by 2, we'll get 2 by 2, and R prime will comes out to be 1 ohm. So student, Rp prime comes out to be 1 ohm. Now student, this Rp prime and R7 are connected in series combination. Rp prime and R7 are connected in series combination. So student, we will get the equivalent resistance as Rp plus Rp prime plus R7. Rp is 1 ohm, Rp prime is of 1 ohm and R7 is also 1 ohm. So we will get 1 plus 1 plus 1, which comes out to be 3 ohm. So the equivalent resistance between P and Q is 3 ohm. So the equivalent resistance between points P and Q is 3 ohm. Student, I hope this question is very clear to you. Now we shall solve another numerical. Now student, let's discuss another numerical, and the question is, find the equivalent resistance between points P and Q. And student, the network which is given to us is this is point P and this is point Q. This is 1.5 ohm. This is 2 ohm. This is 100 ohm. This is 10 ohm. This is 100 ohm. This is of 15 ohm, 25 ohm. This is 4 ohm, 2 ohm, 6 ohm, 3 ohm. So student, what's the question? That we have to find out the equivalent resistance between points P and Q. Now student, let's solve this question. This is another a complicated network which is given to us, but student, we can convert it into a simple network. Student, for this, let us consider that a battery or a cell is connected between these 2 points. Now student, current will go like this. Student, now when current comes here, it gets divided into these branches like this. Now student, at this junction, student, the circuit is not completed along this side, so current will not flow through this resistance, hence this resistance is omitted, so current will come like this. Student, here also the circuit is not completed, so current will not go or not flow through this resistance. Similarly, here also current will not flow through this resistance. Now student, here the cross sign indicates that circuit is not complete, hence current will not flow through these resistances. So now student, these 2 points, let's name it as A and B. Student, these 2 points are connected with a connecting wire. Student, whenever in a circuit 2 points are connected, it means these 2 points have same potential, or we can say that these 2 points are short circuit. So student, due to short circuited, these 2 points are at equal potential, so current will not flow through 15 ohm and 25 ohm. Hence student, these 2 resistances are also omitted. So student, A and B are at same potential. Why they are at same potential? Due to short circuit. So student, these 2 points are connected with a connecting wire, and hence student, these 2 has been short circuited. Therefore, these 2 resistances are omitted, or current will not flow through 15 and 25 ohm resistance. So current will not flow through 15 ohm and 25 ohm resistance. Now students, see here that we have omitted these resistances from the circuit. Now see, let's name this resistance as R1, this is R2, R3, R4, R5 and R6. So students, see here, this complicated network which was consist of lots of resistances, now it is consist of only resistances which are R1, R2, R3, R4, R5 and R6. Now student, we can see here that as the current will not flow through the 100 ohm resistance, therefore student, R2 and R3 are connected in series. R2 and R3 are connected in series. R2 and R3 are connected in series. So student, we will get the equivalent resistance by adding R2 and R3, which is 2 plus 4. We will get the equivalent resistance as 6 ohm. Now student, the equivalent resistance, which is RS, R4 and R5, are now connected in parallel combination. RS, R4 and R5 are connected in parallel combination. Therefore, student, we get the equivalent resistance as 1 by Rp, which is equal to 1 by Rs plus 1 by R4 plus 1 by R5. Rs is 6 ohm. So 1 by 6 plus 1 by 3 plus 1 by 6. We'll get the LCM as 6. Here we get 1 plus 2 plus 1 in the numerator. And we get 2 plus 1 is 3 and 1 4 by 6, which is 2 by 3. And we get Rp as 3 by 2, which is 1.5 ohm. So student, we get Rp as 1.5 ohm. Now students, see, R1, this Rp and R6 are connected in series now. Now R1, Rp and R6 are connected in series combination. So we'll get the equivalent resistance, R equivalent between points P and Q will come out to be R1 plus Rp plus R6, which is 1.5 plus 1.5 plus R6 is 2 ohm, which is 5 ohm. So student, the equivalent resistance between P and Q comes out to be 5 ohm. So the equivalent resistance between points P and Q is 5 ohm. Student, I hope this question is also clear to you. Now let's discuss another numerical. Now student, let's discuss another numerical, and the question is, in the given network, what is the reading of ammeter? And the student, the network given to us is this is of 10 ohm, 10 ohm, 10 ohm, 10 ohm, 10 volt. And student, ammeter is connected here. Now student, in this question we have to find out the reading of this ammeter. Now let's solve this question. Students, see, the current is going like this. Now student, as we can see here that all the resistances are connected in parallel combination. So current will get distributed like this. Student, we can find out the value of current. We can see here that as all the resistances are equal, therefore equal current is flowing through all the resistances. So student, now we can find out the value of current. Student, the equivalent resistance R, we can find out 1 by R is equal to 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10, which is 5 by 10. So R comes out to be 10 by 5, which is 2 ohm. Now student, V is given to us as 10 volt. So using Ohm's law, we can find out I, which is V by R, which is 10 by 2, and this is 5 ampere. So student, a total current of 5 ampere is flowing through the given network, and student, as the resistance of each resistor is same, therefore the current of 1 ampere is flowing through all the resistances. 1 ampere, 1 ampere, 1 ampere, 1 ampere and 1 ampere. Now student, if I name these three resistances as R1, R2 and R3, student, we can see here that this ammeter is connected in series combination with the parallel combination of R2, R1 and R3. So student, this ammeter will read the current flowing through R1, R2 and R3. Now students, see, this current of 1 ampere will pass through the ammeter, this current of 1 ampere will pass through the ammeter, and this current of 1 ampere will pass through the ammeter. And student, this current of 1 ampere and this current of 1 ampere will not pass through the ammeter. As student, we can see here that ammeter is connected in series with the parallel combination of R1, R2 and R3. So student, the reading of ammeter will be 1 plus 1 plus 1 is 3 ampere. Student, ammeter A is connected in series with the parallel combination of R1, R2 and R3. Therefore student, ammeter will read the current flowing through R1, R2 and R3. Hence, the reading of ammeter is equal to the sum of the current flowing through R1, R2 and R3, which is 1 plus 1 plus 1, 3 ampere. Hence the reading of ammeter is 3 ampere. So the reading of ammeter in the given network is 3 ampere. Student, I hope this question is very clear to you. Now let's solve another numerical.